Welcome all of you to this video of Maths Made Easy Academy. In today's video, we are going to do calorimetry sums. Okay, now before this I have done the sums of specific heat capacity. Now your chapter calorimetry is divided into two parts. If you have noted it, it is divided into two parts. The first part has sums, has numericals from specific heat capacity, and the second part has numericals from latent heat capacity, specific latent heat, like that. Okay, so in the exam both the sums come. So now today I am going to take up sums only from latent heat. Okay, that is the second part of the chapter. If you want sums from specific heat capacity, you can check my other video which has sums from specific heat capacity. That is the first part of the chapter. So let us quickly start with these sums. These sums are from concise physics, okay, from the exercise. So this, you'll find this sum in the concise physics exercise. I am not telling you the number of the sum. Why? Because with every addition the question number keeps on changing. Okay, so there is no point. You might be using some old addition, I might be using some old addition, so the question number keeps changing. Okay, that is why I'm just taking the sum, but you will definitely find this sum in concise physics exercise. So let's see how to do. Now here the result of mixing 10 gram of ice is there and 10 gram of water is there. Both are at, ice is at -10, water is at 10 degree. Specific heat capacity of ice is given, specific latent heat of ice is given, specific heat capacity of water is given. Okay. Firstly, let me talk about how these sums work. That is not very clear with many people. Now when you have here you have the let's say 0 degree centigrade, here you have 100 degrees centigrade. Okay, now if ice is here at -10 degrees centigrade, ice has to first get the heat to go till here. Okay, ice has to first go till 0 degree, and then, so when ice has to go till 0 degree, what is the heat absorbed for this part? For this melting, for this warming up of ice, I shouldn't say melting, warming up of ice, it is mc theta we have to use, where c is the specific heat capacity of ice. We have to use this value, and m is the mass of the ice, and theta is the difference in temperature. If it is going from -20 to 0, I'll put a 20. It's going from -10 to 0, I'll put a 10. Okay, and here this part we will again use mc theta. Here c will get a different value, specific heat capacity of water it will take, because at 0 it has formed water. Okay, if I talk about this part, if supposing in some sum the sum goes up till above vapor, after vapor also you are heating it, then we again use mc theta here. That c is specific heat capacity of water vapor. Now what do we use here? At this point and at this point. Now these are the 2 points where we use latent heat, because there is a change in state. So here ice solid to liquid state. So here we'll use ml. There is no theta, because change in state happens when the substance is at constant temperature. So here it is only ml, m of the ice, mass of the ice, and L, latent heat capacity, heat of ice. This value we are going to use here. Supposing it goes even after boiling water, it goes to vapor, again here also we use L, but this L, they should give you the value of latent heat of vaporization. Here they should give you latent heat of ice, or latent heat of, also called fusion. Sometimes they might also call it latent heat of fusion. Okay, so this is how the sum works. Now in this question there is some water and there is some ice. Okay, the water is at 10 degrees centigrade and the ice is at -10 degrees centigrade. So water has to provide heat to the ice to melt it. Yes, water has to provide heat to the ice to melt it. Now we'll have to see how much of heat can the water provide. This sum is a very different type of question, goes wrong very easily. That is why I took up this question. Okay, so here this how much of heat lost by the water. Okay, if I write heat lost by water to come to 0 degrees centigrade. That is, the water is losing heat when it is coming in contact with ice. The water is losing heat when it is coming in contact with ice. So how much of heat will it lose? Okay, so again we will do mc theta, because we are taking water is coming till 0 degree. Mass is 10 grams. You have to keep note, if your mass is 10, here also it should be joules per gram per Kelvin. It should not be kg here. Okay, so here specific heat capacity of water, which is a 4.2, I am taking this value, and theta, it is coming down, difference in temperature is 10 degree, because it is coming from 10 degree to 0 degree. Now this is the amount of heat, this much heat, 420 joules, it is ready to give to come down to 0 degrees centigrade. Let me see how much of heat is required for the entire ice to melt and stay as water as at 0 degree. Heat required by ice to melt at 0 degree. How much of heat is that? First, the ice has to come down. So first mc theta, because from minus 10 degree it has to go till 0 degree, then it has to melt, and then it has to be ml. So m is how much? M is again 10. C, this C is this C, this specific heat capacity of ice, this one. So 2.1 into theta. Theta is 10, because it is going difference in temperature minus 10 to 0, so it is straight 10. Okay, so even if you are not following in the textbook, they will give theta minus T, something like that, initial temperature, final temperature. You just see how much is the difference, that is it. Okay, that difference you have to write. And here M is 10 again, and now I'll have to write, because this is the heat taken while it is melting from 0 degree ice to 0 degree water, that is 336. Now if I work on this, if I work this out, I will get, this is 210 plus 3360. Then what I get is 3570 joules. Now do you see something here very interesting? See something very interesting here. The heat that this warm water can give at 10 degree, this water is not very hot. Had it been very hot, the sum would have been different. But here, this, just to come to 0 degree, all it can give is 720 joules. The ice to melt and be at 0 degree only, we are not even thinking of this ice, becoming water and then coming to 5 degrees or something, nothing like that is happening. Okay, only thing is, it is coming till water only and being at 0 degree. It is remaining at 0 degree. This is the amount of heat required, which is a very big amount. So the warm water cannot definitely melt all the ice. Okay. So now what will happen? What can happen is the full ice will not melt. Only some ice will melt and be at 0 degree, because unless the entire ice has melted, the temperature of the ice water mix can't even go till above 0 degree. It will remain at 0 degree till the entire ice has melted. So there will be some water at 0 degree. Okay, this water will also come to 0 degree. There will be some water of this ice, of the 10 gram ice, portion of it will form water at 0 degree and portion of it will remain as ice. Okay, portion of it will remain as ice in that ice water mixture. Okay, now it is our job to see, they told find the result of the mixing. Okay, what is the result of the, now they want to ask us what is the final result of mixing. We will have to tell them exactly how much ice has melted and how much is still in the mixture. Okay, so how do you do that? Let's see. So here we have to understand the heat lost by the water is a 420. Okay, heat lost by the water is a 420, and how much of heat is gained by the ice which is at minus 10 degree. So first we will show how much it takes for the full ice chunk to come to 0 degree. Now the entire chunk of ice to go to 0 degree, it will take the 10 gram M, C is specific heat capacity of ice 2.1 into 10. That is from minus 10 it has come to 10. Difference in temperature. This is specific heat capacity. This is the ice water. This is the mass of ice plus m. Now this entire ice has become water with this help, but then m is the mass which is only becoming liquid at 0 degree, which is only becoming water at 0 degree into 336, means this much of ice will finally become water at 0 degree. So we will only take the heat taken up by this much of ice. So how much is it? It is a 210 plus 336 m, which is 420. So here 336 m is 420 minus 210, which is 210. So mass is 210 by 336. Okay. If we work on this, we will get a 10 by 16, which will come to 0.625 grams. That means you can see only very little ice melts out of 10 gram. Okay, out of 10 gram, only 0.625 grams will melt and the rest will remain as ice. Okay. And the mixture temperature will be 0 degree. So you have to write the answer like this. 0.625 grams of ice will melt and the mixture, the ice water mixture will remain at 0 degree. So the ice, the water, the 10 gram water, the new water formed by the ice and the ice, everything will be at 0 degree centigrade. This amount of ice will only melt. Okay, so this sum is, if you just do heat lost, heat gained, you will not be able to manage this question. Okay.